A Nobel Prize victor in physical science cautions that the James Webb Telescope has found something that doesn't come from our universe. Roger Penrose claims that there was one more universe before our own. It's conceivable that the old systems the Webb telescope shows us are relics of this forerunner universe. Different researchers are taking this intriguing hypothesis even further, suggesting that we have already gotten messages from an equal world. Roger Penrose and his conformal cyclic cosmology, CCC, or CCC for short, have caused quite the stir lately. The Nobel Prize-winning physicist introduced this disturbing work in 2015, before the James Webb Telescope was even in operation. Penrose is considered a brilliant yet controversial scientist, and his work extends far beyond the limits of known galactic and cosmological methodologies. Penrose combines quantum physics with consciousness, the evolution of the universe with vast patterns of creation, and he demonstrates that his perspective is totally viable with existing mathematical models. Conformal cyclic cosmology is a theory that states that the universe as a whole didn't start with the Big Bang. The Big Bang merely proclaimed a new cycle in an endless series of creation and annihilation. When our universe was born, there was nothing before it but a forerunner universe. We are part of an endless pattern of cycles, a concept that may be difficult to imagine, like Eastern thoughts of reincarnation. Penrose claims that not only is this true, but a universe can bring certain properties with it from a past life. This is similar to the Eastern idea of karma. The newfound ancient universes and incomprehensible black holes could be such karmic phenomena. They have not been fully reproduced but are the delayed consequences of an older universe. We are currently in an APO of universal evolution. Until recently, scientists viewed this evolution as having a beginning, a middle, and an end. No one could explain what came before or what should come after. The typical answer was simple: nothing. However, quantum physics teaches us that nothing is truly impossible. So what's the answer? Roger Penrose says the solution is that a universe is a dynamic entity with a lifetime, much like stars and planets. Universes exist in APO, and each of these APOs starts with a Big Bang. Eventually, the universe ends in a state of extreme expansion, when all matter has been depleted and physical forces have come to a halt. Space itself falls. The universe breaks down, waits briefly in a state of perfect equilibrium, and then reproduces itself from within. In this process, all the information of the past universe is never lost, similar to how spirits carry their experiences from past lives with them in the concept of reincarnation. Exactly the same thing happens to the universe. Since the framework for recreation is always present and does not need to be created, matter is formed much faster in the early APO of a new universe than previously accepted. The universe remakes itself incredibly quickly from an invisible network. It's even possible that some immense black holes could remain during the transition between APOs. These black holes could act as colossal stores of information from which the universe reproduces itself. Does that sound insane to you? Well, I can tell you that Penrose's hypotheses are numerically and physically sound. Penrose isn't just some crazy scientist either. The Brit is considered, alongside Stephen Hawking, to be one of the greatest astrophysicists of our time. The possibility of conformal change, the APO, and the endless cycles in the universe is completely viable with the principles of Einstein's theories of relativity and other standard works in physics. Penrose presented groundbreaking new evidence in 2015. At the time, some scientists proclaimed him mad, with a few even going so far as to suggest that Penrose had lost his mind when he first hypothesized his CCC ideas. 7 years later, his work has become more relevant than ever. The latest pictures from the James Webb Telescope show galaxies at the edge of the universe that are so old they shouldn't exist. Other pictures show black holes that are so large they should be billions of years old. Yet, according to our old cosmology, they existed shortly after the Big Bang. These two peculiarities don't fit into our old cosmology, according to which the universe arose from nothing 13.8 billion years ago and is unique. But they do fit into Penrose's cyclic cosmology. As early as 2015, Penrose connected these remnants of black holes from the past APO to the cosmic microwave background radiation. He argues that round heat spots in the radiation could be evidence of the disappearance of black holes from a previous universe. Now, it even seems that some of these black holes may have survived the transition from one universe to another. Penrose has been able to demonstrate with certainty that this is computationally possible. What's more, that this reality would try and support his speculations. The inquiry remains as to what the very grandiose development from one universe to another looks like. Is one universe like the next, or is there a further improvement of some sort occurring here too? Roger Penrose has an intriguing perspective. He expresses that from APO to APO, changes in actual properties and matter are conceivable. It is subsequently very conceivable that different universes were identical representations of our own, or that time ran in an unexpected way. Inside these spaces, the CCC backs the mirror universe. Isn't it mind-blowing? Imagine a universe that is mirror-rearranged to ours, and in which time runs in reverse. As indicated by Penrose's thoughts, such a universe might have existed before time. Be that as it may, it could also exist in alignment with time. Researchers who support Roger Penrose's CCC contend that we should then, at that point, also open ourselves to the possibility of the multiverse. Quantum physics has long hypothesized that it's significantly more probable that our universe is only one of incalculable others within the multiverse. All possible kinds of universes can exist in parallel, successively, or consistently. For instance, a mirror universe could exist close by ours and have quantifiable properties that are transiently and genuinely inverse to our universe. In this universe, time runs in reverse, conversely to our forward time. Researchers call this idea anti-time, and it's totally consistent with findings from quantum physics. Even Einstein's relativity conditions can't bar a multiverse. A few specialists even suspect that the secretive dark matter could, in fact, be particles from a mirror universe. The particles travel through a sort of edge district which we can't measure into our space and add to the gravitational impact here. In like manner, there is presumably no fixed limit between the universes. However, maybe there are advances and limits that at present evade our discernment. Anyway, hints of such limits could be present even in the universe. We might have confused them up to this point. Computations have now shown that an anti-universe might help make sense of the incredibly quick expansion soon after the Big Bang. The assumption is backed by the CPT symmetry, which states that the universe, as a whole, should remain symmetrical under the combination of charge conjugation, C, space reflection, P, and time inversion, T. In this situation, an anti-universe running in reverse in time would be the ideal complement to our universe. Such a model would make a total balanced unit. This wouldn't only perfectly make sense of expansion but also peculiarities like dark matter and exaggerated space. What is exaggerated space? It is a sort of space-time math that directly follows from these thoughts. Such a space extends vastly and is adversely bended. The shape is suggestive of a limitlessly enormous seat. In the thought of an anti-universe, exaggerated space gives the structure in which our universe and the counter-universe coincide and supplement each other evenly. An exaggerated space contrasts from ordinary Euclidean geometry in the different way of behaving of lines and points. In exaggerated space, parallel lines veer endlessly further, rather than staying lined up in Euclidean geometry, where parallel lines always stay at the same distance from one another and never meet, regardless of how far they are extended. In an exaggerated space, the negative ebb and flow of space-time would be coherent, and the limits of a universe would be open so that space and time can continue to exist beyond the visible region. You can imagine the advances between the universes as pools of water that line one another. Because of the negative ebb and flow, water, and maybe matter, sloshes this way and that between the different pools. If the water flows into another pool, it blends in with different circumstances there. Exaggerated space supports the possibility of an limitlessly extending universe in which the calculation of space-time not only gives the structure but is the air conditioner of fuel for development and advancement. Consolidated with the expansion theory, the pocket universe is made by this exaggerated space. A unit and the individual universes emerge in the supposed pockets of this space. An exaggerated universe might actually make sense of how a universe can more than once make itself out of itself through ebb and flow alone, and the theory supports the thought of Roger Penrose's cyclic cosmology. The consistent state universe. When we examine new ideas for understanding the universe, the consistent state thought should not be missing in this cosmology. Our universe exists in boundless time and appears to be identical at each moment. There is neither a beginning nor an end in this universe. Development happens through a ceaseless progression of matter. This matter could hypothetically come from equal universes. We can use the model of the water bowls once more and envision the thought as water being taken from one bowl to another through spouts. The resulting flow makes the impression of an extension. Anyway, the space is still limitless in existence. The vortices and flows run out inside the bowl, and our universe also has releases into other universes. The thought was developed as early as the 1940s by three American physicists named Fred Hoyle, Herman Bondi, and Thomas Gold. Initially, the theory was dismissed because it was apparently incongruent with the peculiarities of cosmic microwave background radiation as a leftover of the Big Bang. Anyway, current perceptions show that background radiation has often been misunderstood in the past. Specialists have even tracked down proof of crashes with different universes in the radiation. This infinite scar tissue could support the possibility of the multiverse, and it could provide proof that the background radiation has an unexpected origin compared to the Big Bang. Buy in now and never miss another video.